So here we're going to talk about first domain log functions. And we'll use this for graphing. So when you have a log function or ln function, this is the same. So whenever I use, so this is also whatever I say, it's also true for ln function. So if I write this, let's say log a, and then here you have an input, right? So the expression or the number that we have here is called the input, right? So maybe I'll just say an input here, whatever that input is. It could be an expression. So input is number or be an expression. So then to find the domain, the restriction that we have for ln function is that input must be strictly bigger than 0. Okay, and this is an inequality, right? So when you write this thing, this is an inequality, so you have to solve this. So then the next step will be solve the inequality and find the restriction on the variable, right? So that's basically it. This is as simple as this, but we have to do some example to practice with this. So here is an example. Say I have this function log base 2 2x minus 3. So what is the domain? What is the domain of this function? Like we said, the input must be strictly bigger than 0. So whatever you have here, whatever you have inside here is called the input. This has to be strictly bigger than 0. So then I'm writing the inequality now. 2x minus 3 must be bigger than 0. Then I'm solving this. Okay. And after I solve this for the variable, and that's what I have the restriction. So 2x, add 3 to both sides, and then divide both sides by 2. So that's 3 over 2. That is the restriction we have for the x value. If I want to plug in an x here to compute the corresponding y value, and that x has to be strictly bigger than 1/2. So then I'll write it like this. Domain should be from 3 over 2 to infinity. Okay. All right, so let's look at the next example. Okay, we have this log. This time, let's choose an ln function. So ln, let's say ln x squared minus 1. This time, I'm going to choose a quadratic input. Okay, so what is the domain of this function? What is the domain? Again, I'm going to take this input here, this input right here, and make it strictly bigger than 0. So x squared minus 1 is bigger than 0. But this is a quadratic inequality. So you see, linear was simple. You just have to add numbers or subtract numbers from both sides and then divide or multiply. So that's like a two-step thing. But this will be a little bit more involved. So this is called quadratic or nonlinear inequality, quadratic inequality. To do this, first I'm going to have to, step 1 is like factoring this quadratic function first, or quadratic expression. And when you factor it, it's x minus 1, it's x plus 1, bigger than 0. Then set each factor to 0 to find the x values. So x minus 1 equals 0. This will give you x equal 1. X plus 1 equals 0. This will give you x equal to negative 1. And then put both of this on the real line. Negative 1 here, positive 1 is here. And then test it and see what numbers or what numbers will satisfy this inequality. Okay, so let's say I'm going to test here. So I go from 1 to infinity. I'm just going to pick a random number here. Let's say I pick x equal 2. And when I plug it in, it's going to be 2 squared minus 1, which is going to be 3. And 3 is bigger than 0. So yes, this one satisfies. So 1 to infinity is going to be one of the pieces of the domain. Maybe there are more pieces here. I just have to check and see. Let's say between negative 1 and 1, I can test 0. I can choose x0. then I will plug it in. So 0 squared minus 1 is -1, and that's not bigger than 0. So this is not going to work. And then I will also test right here. Test this one now. So I can pick x equal -2, plug it in. So -2 squared minus 1 is also 3, and 3 is bigger than 0. So this one is yes. This one also satisfies it. So then now I have two things, -infinity to -1 union 1 to infinity. So then the domain overall is going to be this. So you see with the nonlinear, we have to do more stuff to find a domain. Okay. So now this will be useful when you're actually graphing a log function as well. So, and then the log function will also have something called vertical asymptote. So log, let's say this is log base A, and this is again an input. So a vertical asymptote is going to be input equal to 0, and then solve this. Then you have the asymptote. So here is an example. So let's say you have log base 5 minus 3. That's your function. This is your function. The vertical asymptote is just going to be input equal to 0. So this guy 0, and this will give you x equal to 3. And this is going to be like that. So we'll also use this for graphing. So let me, okay, so graphing log ln functions. So let's take, when you're graphing, so step one will be, okay, find a domain. Step 2, find the vertical asymptote. And then step 3, maybe you may want to include a table. So make a table. Make a table value. So this 3 things should help you to have some idea. I mean, of course, it will not be a very rigorous graph, but it will give you some idea. Okay, so and then also the graphing technique, the transformation techniques can also be applied. So the simple log function. Let's start with the simple log function. Log 2. Okay, right? So I'm going to graph this. Okay, so first I'm going to find a domain. So the domain will be input bigger than 0, and input is x, so it will be x strictly bigger than 0, or I can say from 0 to infinity. 2, the vertical asymptote is just going to be input equal to 0, so x equal to 0. And then I may just include a table, so I can just do this. So my table is going to look like this, so I will just say x and y, but my x values are strictly bigger than 0, so I can start with 1. If I plug 1, then it's going to be log 2 1. If the input is 1, we always get 0. So maybe at the same time I can plug my points. Okay, so domain is bigger than 0, and the vertical asymptote is x equal to 0. This is vertical asymptote, x equals 0, and then I have a point 1 0, which is this point right here. And then let me try another point. Maybe I'll plug 4. So I don't want to plug, let's say, or I can maybe try 2 as well. If I plug 2, this will be log 2, 2, and that equals 1. So this is going to be 2, 1. So 2, 1, let's say, is right here, and you're going to get a point right here. I don't want to try 3 because log 2, 3 is going to be a decimal, but you can try it. You can plug that in, I mean, this is not like a graphing paper, so the log 2, 3 is a decimal. It's not going to look good, so I'm going to try 4. So log 2, 4, and I can write this as log 2, 2 squared, which is going to equal to 2. So I have 4, 2, 3, 4, 1, 2, 3, 4, and then 2 is going to be somewhere right here. So it looks like this is going like this, and then I will also have a piece that is going down, never crossing the asymptote. So this is like the parent function. You can think of this like a parent. And if it's transformed, then you can use all the transformation rules and graph it. But usually it's just a simple 3 steps. Okay, so let me just give you guys a different example. So here is like this. So let's say ln of is 3. Okay, so first I'm going to find the domain. As always, domain is going to be input bigger than 0. So x minus 3 bigger than 0. And if you solve this, this will be x bigger than 3. Or you can say from 3 to infinity. To the vertical asymptote. So vertical asymptote is just going to be input equal to 0, which is x equal to 3. And then I can make a table now. So 3, let me just make a table right here. And my x values are going to be bigger than 3. So I can start with 4. Then ln 4 minus 3 is ln 1, which is 0. So I have 4, 0. And you can try any other number after this, like try a bunch of other numbers. You can try 5, which is going to be ln 5 minus 3, and that's going to be ln of 2. So let me see the value of ln 2. We can sort of approximate this number, and that is okay. Ln of 2 is like it's like 0.69, approximately 0.69. And you can try any other number you want after this. So 6 minus 3 is going to be ln 3. So ln of 3 is approximately 1.09, right? So just use this table also, and then you can graph it, and it's going to look like this. So you can put more details if you want, but my simple graph is going to look like this. So 1, 2, 3. So the asymptote is x equal to 3. That's a vertical line. The vertical line x equal to 3. And then I have this point here, which was 4, 0. And then I'm going to start getting like points like this, and points like this. So therefore, the graph will be basically just this. If you just follow this way, then you'll always come up with the shape like this, or sometimes you're translating, sometimes you're reflecting, so those may involve as well, but you can just follow those steps and you will never go wrong. So this is ln x minus 3. And we discussed in the other sections that this is actually the inverse graph of the exponential function.